Hello guys. Uh, Today my video is about micromechanical pressure sensors. Uh, as you all know what is a sensor and what a sensor does in automobile industry, uh, what part of life it plays in our life, what kind of role they play in our life in automotive industry. So what is micromechanical pressure sensor is? It is a pressure sensor. Basically, it is a pressure sensor, small in size, which could be equipped in our automotive vehicles. Uh, this concept was released by the Bosch company, and currently they have used one of the micromechanical pressure that is peripheral pressure sensor. The name of the sensor is peripheral pressure sensor, and it is used for airbag conditions and all. So we'll look more into it. So basically, what is a sensor? Uh, it is a device used to measure a physical quantity and convert it into an electronic signal without modifying the environment. That is what, and there are various parameters that a sensor can be used to determine, that is temperature, voltage, pressure. Many parameters could be sensed with the help of a sensor. So when we look into micromechanical pressure sensor, those are sensors that are used to determine the absolute pressure of liquids and gases by measuring the pressure differential in the reference in relation to a reference vacuum. Then let's look into its design. So this sensor is basically made of a silicon chip. The blue color which you see and marked as 2 is the silicon chip, and the one which is marked at the top is the diaphragm. And on the diaphragm we have equipped with 4 resistors, 4 strain gauge resistors, and those are the resistors which are shown in the below of the diagram. These are the resistors R1, R2, R4, R2. How it works is that when this diaphragm comes in contact with a high pressure, the value of the resistors get changed, and a voltage will be produced at the top of the diaphragm in response to the pressure acting on the diaphragm. So let's look into more detail. uh, the measuring cell of a micromechanical pressure sensor consists of a silicon chip in a thin with which is thin diaphragm is micromechanically attached. As I said, it is made of a silicon chip and with a diaphragm at the top. Then four strain gauge resistors R1, R2 and another R1, R2 are diffused in the diaphragm at the top. The electrical resistance in these resistors change in response to mechanical elongation. So I told, as the pressure on the diaphragm increases, the diaphragm gets elongated. So the measuring cell is surrounded and sealed on its component side by a cap which encloses the reference vacuum underneath. So all this which is equipped uh, under a cap like uh, substance. See the white color which is seen is the cap which encloses the sensor. And what is the main operating principle is that the diaphragm of the sensor cell is deflected to varying degrees depending on the external pressure acting on it. The diaphragm is deflected by 10 to 1000 micromillimeters, and the four strain gauge resistors on the diaphragm change their electrical resistance as a function of the mechanical stress resulting from the applied pressure. This is what I said, as with the uh, applied pressure, the values of the strain gauge resistance gets varied. Then the four measuring shunts are arranged on the silicon chip so that when the diaphragm is deformed, the resistance of two of them increases and that of other two decreases. So when this happens, uh, the ratio of these two resistors R2 by R1 will not be equal to R1 by R2. When this condition gets occurred, voltage will be applied in the would be occurred in the center. So that is in response to a measure which response to pressure which is applied at the top of the diaphragm. So then The restors are connected in form of Wheatstone bridge. It is working on the basis also on the it works on the basis of Wheatstone bridge too. And so these measuring shunts are arranged in a Wheatstone bridge, and a change in their resistance values leads to a change in the ratio of the voltages across them. This leads to a change in the measurement voltage B. Then this has yet unamplified voltage is therefore a measure of the pressure applied to the diaphragm. The measurement voltage is higher with the bridge circuit would be the case of an individual sensor were used. So what it is saying is that the accuracy of the voltage which is being measured would be greater when a Wheatstone bridge is used than a single resistor was used. So that is what it is indicating over here. Then the Wheatstone bridge circuit thus permits a higher sensible sensitivity. That is what it gives a higher sensor sensitivity. That is why we are using Wheatstone bridge. So then the signal conditioning electronic circuitry is integrated on the chip. Its function is to amplify the bridge voltage, compensate for temperature influences, and linearize the pressure curve. The output voltage ranges from 0 to 5 volt and is supplied through electrical connections to the engine control unit. So the engine control unit in the car would be getting the voltage from the sensor, and the voltage would be ranging from 0 to 5 volt. The control unit uses this output voltage to calculate the voltage. So what the ECU does is that from the voltage which is getting from the sensor, we get from the sensor would be used to calculate the pressure that is being encountered with the diaphragm. So it's applicable. Look into its applications. So PPS2 is the sensor which was released by the Bosch company, and it is designed for the airbag application. So this is the uh, PPS2 which was released by the Bosch company here. And when we look into its working, the sensor system was designed for side impact detection. That is, the sensors were deployed in the were equipped in the side doors of the vehicle. So unlike the front, the front of the vehicle, the side has a limited crumple zone. Crumple zone means the front of the vehicle and the rear part of the vehicle. So that is what is mentioned to ensure enough time for the activation of the restraint system following an impact. The airbag control unit must decide in less than 5 milliseconds whether a deployment is required based on the type and severity of the crash. So what it mentions is that uh, the sensor which is equipped in the side of the vehicles would should detect whether uh, whether it should deploy the airbag within 5 milliseconds, and this uh, deploying of the airbag within 5 seconds, they should decide uh, whether the pressure, that is if it is a slight small pressure which is getting occurred, then it need not to be, it shouldn't deploy the airbag. If it is a greater pressure on the side door only, it should deploy the airbags. That is what it is saying, and this decision need to be taken by the sensor within 5 milliseconds. That is what mentioned in this point. Then the operating principle, uh, the peripheral pressure sensor is installed in the door cavity, providing fast and robust side impact detection. That is what I said. It provides a fast and robust side impact detection. That is, it deploys airbags. It takes decisions to deploy the airbag within 5 milliseconds. The sensor continuously measures atmospheric pressure and detects any change resulting from a deformation of the door. That is what it continuously measures atmospheric pressure. So if it is a higher pressure that leads to a deformation of the door, it deploys a airbag in the vehicle. So in comparison to central sensors, the peripheral pressure sensor makes it significantly easier to distinguish between an actual impact and harmless impulses by means of continuous pressure distribution within the door interior. The entire door acts as a sensory element. So by means of continuous pressure distribution. So what it is showing is saying is that so this when this sensor is equipped in the side of the door, the complete door acts as a sensory element. So when there is a collision between a vehicle and the side of the door also takes part in this working as a so has when a collision occurs the door, so this pressure also is being sensed by this PPS2 sensor, and it deploys the airbag. That is what is mentioned. So we'll move into the configurations of PPS2. So depending on the vehicle application, two or four peripheral pressure sensors are connected to the airbag control until alongside the peripheral acceleration sensor on the supporting structural components. So we can either equip the vehicle with two pressure sensors or four peripheral pressure sensors. That is what was mentioned. And so therefore by combining these two physical measurements, that is the peripheral acceleration sensors and peripheral pressure sensors, a quicker and more reliable deployment decision can be made for passive safety systems. So based on these two measurements, we can use it for deploying the airbags. So with the deployment of airbags, they can uh, 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 more they can more uh, uh, protection. They can use it for more protection of the person who's sitting in the vehicle. The peripheral sensors verify the triggering decision more quickly than lateral acceleration sensors integrated into airbag control unit. So so it the same what is saying is that same point itself it is continuously telling that is that it verifies the triggering decision more quickly than lateral acceleration. It works, that is the peripheral pressure sensors more work more than the acceleration sensors. And what the technical specifications of the pressure sensor is that it can measure a range of 50 to 126.5 kilopascal. It is a measurement range of the PPS2 sensor, and minus 5 to plus 15%. It can measure the pressure range, that is what, minus 5 to 50 plus 15%. And benefits to the manufacturer. So it deploys a faster airbag in the event of a side impact, then robust firing decision in combination with acceleration sensors. So that is what it in order to have a robust firing decision, it should act within 5 milliseconds. So and small and cost effective sensor design, the design which has been used in this is small and it is within the it is cost effective, it is much less in cost, and flexible mounting concept. Okay, then the more applications where this peripheral pressure sensor can be used or micromechanical pressure sensor is used is in the intake manifold pressure. uh, the diagram which I have been shown in the diagram is that this is an intake, this is the intake manifold. What it does is that it supplies the air which is sucked from the atmospheric, and this supplied air is mixed with the fuel for the powering up of the engine, we can see like that. So what it does is that uh, it is like mm, it is a part of the engine. This intake manifold is used. It is a part of the engine that supplies the air into the engine. So it distributes the air evenly into each of these cylinders, which you can see in the diagram, so that it can mix with the right amount of fuel and give uh, make the engine to work more efficiently. That is what turbo. That is what intake manifold pressure is. So to measure that intake manifold pressure, we can use a micromechanical pressure sensor. Then another application is the boost pressure for boost pressure control. So boost pressure is so the micromechanical pressure sensor can be used to measure the boost pressure also. So what is a boost pressure is that in the case of a turbocharged engine, this diagram which I have shown in the slide is a turbocharged engine. So what is a turbocharged engine and where it is used is it is mostly used in vehicles where we need a more power, much more power, maximum torque, and the engine works with maximum efficiency. So what does a turbocharged engine does is that it compresses the air. The compressed air would be having high pressure. So this uh, pressured air would be mixed with the fuel in right amount so that we can get maximum torque from the engine and maximum efficiency also from the engine. So to measure that boost pressure and that uh, boost pressure in the turbo engine, we can use a micromechanical pressure sensor. That is what is mentioned. And then another application is the ambient pressure. Ambient pressure is the the pressure which is surrounding the vehicle. It could be a hot time or it could be during the cold time also. So to measure this vehicles could be moving in the during the hot duration or during the cold duration. So to measure that pressure, so that is also being used. And then oil pressure to take engine load into account in the service display to measure the oil pressure. And then the fuel measure for monitoring the level of fuel filter contamination. So it also can be used to measure the fuel pressure. And these are the applications that can be used with the help of micromechanical pressure sensor. And that is what I was plan to say today on micromechanical pressure sensor. I hope it has this presentation has helped anyone and will help anyone and who are willing to know more into sensors that has been used in the automotive industry. Thank you. Thank you.